Hey, my name is Chris Davis. I'm going to be demoing how to analyze PowerShell malware by using the code that the malware author gives you. Again, I just said my name is Chris Davis. I'm a senior technical analyst for CounterHack, challenge developer / pen tester, GSC number 144, have the OSCP and a bunch of other certs. So tools that I'm going to be using for this demo are PowerShell ISE for debugging. I'm going to be using Wireshark. I'm going to be using Process Monitor, ProcDump, PowerDump, which is a quick little script that I wrote up. Really, it's just strings on steroids, gives you a little bit of extra versatility, but basic logic built in, but nothing too special. Outside of that, we're using Olevba, which is going to be, or it's a Python OLES tool library, which allows us to pull VBA macros out of a Word document safely. Again, the thing to keep in mind here is that we want to practice OPSEC always. We never want to run malware or analyze malware from our host system or host environment, right? So we don't want to run that on our production machine or production network because we could be giving ourselves away. We could be spreading the infection further, right? If we start interacting with the C2 server, for example, we might be giving ourselves away, and that the hacker might change his tactics at that point. That's why typically I always run it in a virtual machine or a Docker instance, and then I also typically always have a VPN set up as well, so that if I do generate traffic and I am touching or interacting with the C2 server or the malware author's server in some way, shape, or form, again, it's coming from a different IP address, so I'm not giving my organization away at that point. Okay, so for this part, we're going to imagine that we've just came to a machine that was we suspect is infected. The user had reported that they got a malicious email. They opened that email. It looked like it was from Amazon, saying that they had received their invoice for a very large order. So they opened it up and they saw something like this, for example, right? At this point, obviously, we wouldn't do that on the machine there. We wouldn't want to enable the content, especially. What we would do is we'd take the document off, move it over to a virtual machine, and then maybe inspect it further from there. So we would take this document, again, move it onto a virtual machine of some kind within a segregated, safe environment. And then let's go ahead and change into that directory. And now this again assumes that you had done the pip install OLE tools, so that we'd have the OLEVBA command available to us. Actually, let's make sure that we got that file here. Yeah, okay, OLEVBA.exe, and then we're going to give it the name of our docm. As soon as we run that, we immediately see that there's a VBA macro here with auto open available to it. And then inside of here is a PowerShell.exe script with the -w hidden flag. So what the -w hidden flag means is, okay, so we suspect that there's probably a malicious PowerShell running somewhere on the machine. So we would probably open up our task manager and we would see, yeah, I don't see this here, right? There's nothing in here as far as we can see. And I think if we even ran a PowerShell command of get-process, we wouldn't see the PowerShell command in that either. It's because of this -w hidden command. But fortunately, there are tools that allow us to be able to see those hidden processes. For example, Process Explorer, which is what I'm going to demo here. We can actually run that as an administrator. And as when we do, it's a little bit more versatile. It has a lot more tools built into it directly and gives us a little bit more power over viewing processes and managing processes. And so here, again, we can actually see that there is a PowerShell process running on the machine. So in an incident handling scenario, especially if it's a new malware that's not seen, you don't really know what's going on with it, at this point, what we would probably want to do is go ahead and take a process dump of that. So we're going to take a process dump of that. So again, fortunately for us, let me change into my admin tools folder. And we have the procdump -ma. And we're going to grab that process ID here. So we're going to grab 6616. 6616. This, again, is assuming we ran that as administrator. Okay, so it created a process dump for us here. So now we have a process dump. Okay, so at this point, we've taken our memory dump of the hidden PowerShell process that was running on the actively infected machine. Again, at that point, we would probably hand that off to the incident handling team to decide on what they wanted to do with that, whether they wanted to kill the infection immediately, or perhaps they wanted to study it a little bit further and what it was doing on the machine, see if it pivots somewhere else, whatever, right? We don't care about that. Again, we're just doing the malware analysis piece. That's incident handling on that is outside of the scope of what we're doing here. So onto the malware analysis piece, as we had done before. Again, we had our Amazon here. I'll run this olevba command one more time. evba.exe, Amazon. And again, we had gotten our malicious PowerShell process. That's how we found out that it was running as PowerShell, and we grabbed that memory dump. But so anyways, we need to take this malicious PowerShell and study a little bit further, right? We need to figure out what it's doing. We can see from here that it's using base 64, and it's also compressed, likely gzip compression. So the first thing that it would have to do here is we would have to come up with our own custom coding to be able to convert this from base 64, and then once it's converted from base 64 to gzipped binary data, we'd have to ungzip it and then to its plain text format. Now, again, we could code up our own custom format for all of this, right? We could make a Python script that would go through and do those things for us, or we can just use the command itself, use the command that the malware author provided us, right? So what we're going to do is we're going to take away that dash hidden command because we don't want it to be hidden. We actually want to be able to see what's going on. VBA macro has a specific escaped format for quotes, so we're going to remove that, and now it's in the proper format. So now the thing with PowerShell is basically what's happening is it's pulling a string down, converting it from base 64, then converting it to gzip, and then converting it into a regular string. And then it's using IEX, which in PowerShell is invoke expression, and it's executing more PowerShell basically. But so we can just remove that IEX so that it doesn't execute it. And instead of executing it, we're going to have it out to a file, out-file, and we're going to say dropper.ps1. Okay, so there's dropper.ps1, and when we look at that, it's just more PowerShell. So the PowerShell that's inside of that is actually gzip encoded data that says, hey, let's invoke a web request. Well, let's go to this URL and download something called not enable ps file.css. Okay, that's suspicious. So once again, we see this IEX here. So we can get rid of that IEX. Let's go ahead and highlight this content. And again, we're just using the code that the malware author gave us. We're just changing it up a little bit. So we're going to once again, just out-file. We're going to go with source.ps1. And we see there's our source.ps1. We're going to take a look at that real fast. And looks like our source code for the malware. So we need to do a little bit further analysis on this. It's kind of hard to see that from a terminal. So let's actually go ahead and open this up really fast. See if we can clean this code up. Maybe get a better view from it. I like to use Visual Studio Code. Again, you don't have to use Visual Studio Code. This is just my own terminal editor or text editor that I like to use the most. So as we can see, this is kind of a pain in the butt to read. So at this point, probably what I would do is I would try to clean this up. For example, it looks like they have everything on one line. Let's go ahead and get rid of. Let's go ahead and change everything to new line characters. And then actually I could go through and spend the next couple minutes cleaning this up, but I'm going to go ahead and skip over that part and I'll come back here in a second. Okay, at this point I've taken a little bit of time to clean it up. Basically I just did like replacing semicolons with new line characters and then did some tab indenting just to make it a little easier to read. So the first thing we can see is that there's some crypto function here creating an AES manage object. Looks like maybe some kind of conversion functions here. Then we have an encryption function, and then a decryption function, and then we have a main function named hacks, which is being called at the very end of the source file. So before we actually do, we're not going to actually just run this from here. We're actually going to run this in PowerShell ISE. PowerShell ISE will allow us to actually set breakpoints and view the data as it's being transmitted, and to call the functions. So let's go ahead and open up our file. We have source. Okay, so at the very bottom we have our hacks. We can do F9 on the very first line to set our breakpoint, and then we'll just take it one by one, step by step. And I think actually before I do that, I'm actually going to comment out this start-sleep, because what it's doing is it's actually going in a loop. It's constantly retrieving something and sending back the results. we don't really care to wait 30 seconds. So we're just going to comment that line out and then set our breakpoint on line 52. We'll go ahead and play. And then as we can see, our C2 variable is not defined yet because it hasn't actually ran that line. So we're going to step over that. And then we're going to step over ID. We can check ID really fast. And we can see that it actually created a random 32-bit length. I think it's 32 byte. Yeah, so it's 32 bytes long. So let's continue to step over that. We don't care about the SSL validation. Here, this is important, right? This is the one that it's trying to hide. So it's making a web request, sending in our ID and our arbitrary value of reg, I guess register. So let's see what the results are. So let's step over that and let's see what key is. So again, if we were monitoring this with Wireshark, or we had our organization had full packet capture, it would see this, but it wouldn't. It would see the request, but it would be encrypted because it's using HTTPS, right? So the only way that we can actually see this key is in memory. And so we have our key, and then we have something being defined called actions, ACTNS. I'm assuming actions. So let's continue to step over our functions here. While true, we're entering our loop. It's defining some parameters with, now it's saying requesting ACT. So it's requesting an action possibly. Here we go into another post request being sent to our C2 server. Let's go ahead and step over that. And so data has just been grabbed. Let's see what the data was sent back. Okay, so data is sent back as just some long string. We can see that it's only hex characters, so it's probably hex encoding. Let's go ahead and decode that hex encoding. Just have a quick online hex decoder. And okay, yeah, so it's just binary data, and that's probably because all of this is encrypted. So it's sending the data over an encrypted channel. So yes, let's continue on. So stepping over this. Okay, so we can see that actions is appending here. Step over that. Let's take a look at that variable. Okay, so it's just saving it in somewhere. And then here we have action is being defined as being decrypted. So let's actually let the function run and see what it decrypts as. Okay, so there's action. Oh, wow. Okay, so that binary data, this binary data here, this encrypted data, actually decrypts using the key that we had grabbed from memory that it was trying to hide from us over the network via it equates to get child item. And now we see that it's actually executing using IEX here. It's executing that command, and it's going to save it to a string named res, or a variable named res. So let's step over this one, and then let's see what the response looks like. Oh, so yeah, it's retrieving the standard out of the command execution, storing it to the variable, and then it's checking to make sure that the command was executed properly. And then let's step over that, and now we have params being defined with the bot ID, the response, and data. And the data is being run through the encryption function here. So if we step over this, we should be able to see our params. And then if we did this data.data, there's our data. So this is actually the encrypted data. So if we actually did decrypt and then our key, we would get back that standard out. So at this point, what it's doing is it's creating a random ID, it's registering itself, it gets back a key when it registers itself. The key is then used to retrieve commands from the server over regular port 80 HTTP requests. It retrieves the commands, decrypts those commands, and then runs them, takes the standard out, encrypts them again, and then sends them back. But on top of that, it's saving them. I'm assuming so that the hacker can look up past history and past commands that it's ran before. I'm assuming that's what that's for. And then we come over here, and again, this is our last one being sent. It's sending it back as a post parameter. So let's step over that. And then it's storing something called die, and it's 200 or request 200, I'm assuming. So if die does not equal 200, then quits, right? Maybe this is its way of killing the bot if it decides it wants to kill it. Okay, so what we're going to do next is take our PowerShell memory dump that we had taken from earlier on the infected machine. We're going to parse that with PowerDump, see if we can find the key in memory and the commands that were run in memory. If we can, then we can successfully decrypt those and know exactly what the malware author is up to. So first thing we're going to do is we're going to want to go to PowerDump, download that. We have that saved here. So I'm going to go ahead and open up PowerShell, change directory to my malware directory. And again, just to stress this again, OPSEC, you should be running this in a virtual environment. Okay, so I'm actually going to drop into Bash for this because it's a little bit nicer. And then Python powerdump.py. Okay, so there's PowerDump. We're going to go ahead and load a memory dump file. We should be able to see it here. Oh, here it is. Okay. Okay, so we're going to load that. Okay, that's loaded. We're going to go back. It's not processed, so we're going to have that process. Now this could take up to 5 minutes for this to run, so I'm going to cut out on this section and then come back once this is done running. Okay, cool. So this actually ran relatively quickly. I had it finished in about a minute and a half. So it did find some script blocks and it did find some variables in memory, which is nice. And it is asking me if I want to save it for quick processing later. This just makes it to where if you have to restart PowerDump, it'll make a little saved file so that we don't have to wait 2 or 3 minutes for that to process. So we're going to go ahead and save that. Okay, so our file has been loaded and it's also been processed. So let's go ahead and jump into the option number 4, which is going to let us search for variables that were stored in memory. So as we can see, once we do that, there's 11,000 possible values stored in memory, strings stored in memory. We need to selectively reduce that down if we can at all possible. So one of the things that we know is it's all in hex, right? So the values will be A through F. So we have A through F. We're going to give it some regex that will do that. So A through F and 0 through 9, because that's the possible range of characters for hex. So and then we're going to say at the beginning of the string, at the end of the string, plus 1 or more of them. So again, that's matches saying at the beginning of the string, and then it's going to be A through F, or capital A through F, or 0 through 9, and we're going to have at least 1 or more possible, so matches. So once we type that in, we now have only 9,010 possible PowerShell variables in memory. So what else do we know about the key? We know that the key was 32 bytes in total length on top of being hex encoded. So let's go ahead and give it a length of equals 32. When we do length of equals 32, we get 7 possible variables that were stored in memory, and we can just kind of click through those and we can see those values. Okay, so there's 7 possible ones. That's not too bad. We can definitely work with that. So let's just go ahead and dump those. It's dumping it to variable values, a file called variable values. So let's jump over here. Let's make sure we save that real fast somewhere here. Possible keys. All right, let's clear this now because we found what could possibly be the keys. We're going to go ahead and clear that, and now we'll go back up to 11,000 possible variables. And now what we're going to want to search for are the commands that were run, right? So at this point, if it's been running for quite a while, it should have quite a big string stored up in memory, a comma-separated value string stored in memory of all of the encrypted commands that it was needing to run previously, or that it had ran previously. So let's look for that, right? So we're going to have the length is at least greater than, I don't know, 1,000. At this point, it's probably going to be pretty large. So once we do that, we get down to 518 variables, and we're going to do matches. We know it's going to have a comma in it, right? Because it's a CSV. Brings us down to 38 PowerShell variable memories, and we know that they're all CSV encrypted hex blobs. So they're all hex values, right? So let's go ahead and do. Let's steal that hex regex that we had from before. So there's our hex regex, but we're going to add in the comma again because it's CSV or delimited. So there, and we're going to close that off. Oh, whoops, I forgot to do matches. Matches, comma, close the brackets, plus 1 or more, at the end of the string and close the quotes. All right, when you do that, we only have 24 PowerShell variables, and it could be storing these in multiple places. That's why we're getting 24. So let's just take a quick look. And again, we're seeing the data that we're expecting to see. So let's just go ahead and dump those now. Okay, so those are also dumped again. Let's go ahead and go in here, move this over, and now we have possible keys and possible commands. Okay, and from here I'm going to jump back over to creating, using the functions that it gave us. We can write just a couple extra lines of code, and we can parse through here until we find the appropriate or the right key that we're looking for. Okay, so at this point we've had PowerDump go through the memory dump. We found 7 possible keys that could be used, and we saved those to a flat text file. And then we also had PowerDump go through and find all of the possible commands, and these are all, again, all encrypted commands. So we can actually take these values now and run over each key and attempt to decrypt each command. And then assuming we get the right key, then we should get a proper and valid command. So that's what we're going to do. So we're going to take these possible keys. We're going to create a new PowerShell file. And in this PowerShell file, we're actually just going to copy verbatim almost everything that the malware author provided to us. So we're going to have a new file here. And you can see here, I've already taken the time to take the keys and put them into an array called keys. And then I took the commands and I put them into an array called commands. And what we're going to do is we're going to actually just loop over each of those. And so that's what I've done here with this code is I've just said for key in keys and for command in commands. And what we're going to do is run it through the decryption function provided to us by the malware author. So we're going to need to copy those commands or those functions. So we come over to our malware source file. We're going to copy everything except for the bot code function, right? Because we don't want it to be a bot. We just want it to decrypt. So we're going to copy everything except for the bot function. Again, we're just using the code provided to us. And then we're going to copy those and we're going to paste them into our new file. So those are pasted. So we have our for loop. And then at the very end of our for loop, we're going to run it. We're going to run the decryption function. And now what's going to happen here is if it is the valid key, then what's going to happen is it's going to print it out in a valid ASCII. If it's not, it's just going to be some binary data, which we don't care about, right? And if we don't care about it, then that's not the right key. So what we've done here is I've taken a little bit of regex, and it's looking through the valid ASCII range, and it says if the decrypted text is valid ASCII, then we know that it is our valid key, which we're going to save, and then we're going to add it to our decrypted commands. And at the very end, we're going to print both of those things. So if this works correctly, we should be able to get our answer. And we did. So as we can see here, we can see the very first command that was run was net user. Then we had ipconfig and then ls. And it looks like the hacker actually ran commands multiple times in a row. But again, we have our valid crypto key here too. So using this information, we can refine our scripts, we can toss it into another for loop, and we can automate the process for all of the infected machines. We can go through each and every infected machine, find the valid key in memory, use that key, decrypt the commands, and then send them back to us, and we'll know what the hacker did on each and every machine across our environment. Okay, so on final note, I just wanted to reiterate, keep in mind that this may not be exactly how all malware authors do it, right? PowerShell commands that web get a string that then executes more PowerShell is very indicative of a lot of common malware. But again, you may have something like Python, a PyInstaller binary with Python code inside of it, or C#. Either way, both the PyInstaller situation can be extracted from the binary, and C# can use something like .NET Reflector, for example, and pull out the entire C# source code. Either way, that remains the same. Don't reinvent the wheel. Use the code provided to you, making small tweaks here and there, and then you can better analyze the malware, debug it, figure out what it's doing, what it looks like, and then maybe from there you can use that to better assist you in your incident handling in response to an active infection, right? Maybe you can find the key in memory that you can then use to decrypt something of important value, right? Also, again, OPSEC. OPSEC is huge, right? You want to make sure that you run these things inside of a contained, isolated environment, whether it's a virtual machine, a Docker image, or etc. Also, keep it segregated from your network because you never know. It might have an active exploit that it could reach out and then exploit something further, even while you're doing your analysis. So whether that's host-only network communications inside of a VM, or maybe you're doing a VPN, right? Just always make sure that you're practicing OPSEC so that you don't trip off the hackers to what you're doing, but also to keep yourself safe. And then again, finally, use all the tools. In this demo, I didn't show it, but I was running Wireshark in the background. I was running Process Monitor so I could see what file handles it was hooking into, registry keys, stuff like that, just in case it did, right? I would rather have that information when I started my analysis than to not have it. Again, Process Dump, Process Explorer, etc. That's it.